Atoms are considered the building blocks of elements, and the mass of an atom is actually concentrated in its nucleus. This is learner's aid, where scholars are made. Take a deep breath. Breathe in and breathe out. The thing is, the air that entered your lungs whilst you were breathing in, and maybe the phone you are using to watch this lesson, or the laptop you are using to watch the lesson, or the chair you are sitting on, all of these things are made up of something very small that you cannot see with your eye. And there are some types of microscopes, like the light microscopes that we use in the laboratories at schools, cannot even help us see these tiny things. These tiny things we are talking about are known as atoms. When we mention atoms, do not think of them as just a scientific idea. No, do not think of atoms as just some scientific ideas. But rather, they are hidden architects of everything we have around us, because they help us build every single thing we see around us. That is what you should think about atoms. In order for scientists to understand matter, as all the things that we have around us, in order for them to understand them, they need to look into atoms critically, meaning they have to go deeper than us, deeper to a level even smaller than their own imaginations. And when they try to understand matter into detail, they found something that actually changed science forever. What did they find? That is what we'll be discussing in this lesson. And that is atom. Interestingly, a long time ago, scientists actually believed that if you pick matter, let's say if you pick a piece of stone, any matter at all, they believe that you can keep dividing this matter forever. You can keep dividing into half, divide the half again. You can keep dividing forever and ever. That is what they believed in, until they realized that there was actually a limit to which you cannot divide again. So they thought you could divide forever, but they got to a level they realized that no, you can keep dividing matter till you get to a level you cannot divide again. And that was what they discovered to be atom. So what exactly is atom? Let's define atom. What is atom? Atom is defined as the smallest particle of an element that can take part in a chemical reaction. It is the smallest level possible of an element that can take part in a chemical reaction. When we say it is the smallest particle of an element, you might ask how small. You see, atoms are so small, really, really small, such that millions of them can span the thickness of a human hair. Just think about that. If you pick your hair, not the length of the hair, the thickness of the hair, that thickness of the hair, millions of atoms can span across it. You can see how tiny, extremely small atoms can be. However, or yet, they determine the property of all matter that we have around us, all substances on Earth. The kind of atom that particular substance contains determine the property of the substance. So you can see that atom is really, really small, but they are so powerful in determining the properties substances tend to have. Now let's look into the atom and look at some discoveries that scientists came up with when it comes to the atom. Interestingly, early scientists thought that atoms were solid balls. Solid, like just a rock, a solid ball. That is what they thought atom to be. But that's not all. There are some also that actually believe that atom is just like some spherical thing with hollow space. And inside it, there are some kind of mysteries out there which they don't really know. So there are a section of scientists that believe that atom is just solid, fixed ball. Some also believe that it's just an empty space filled with mystery. Then came a breakthrough. Although they had these varying beliefs or idea about what atom was, there came to be a breakthrough. Along the line, scientists discovered that atoms actually had an internal structure. It is not just a solid ball. It has an internal structure. And then at the center of this internal structure was a really dense region that they call nucleus. So as science progressed, they found that atoms have internal structure, and at the center, this dense center exists, and they called it nucleus. And inside the nucleus of this atom they have discovered, inside the nucleus lived powerful particles. So you see what they were discovering. Inside, there's a dense region, and in that region, they found powerful particles. And then around this dense region, they found that there are actually smaller particles that move around this dense center. That was what they found. So if you can see the little animation on the screen, they realized that, okay, there is a center that is dense and there are particles moving around it. So they decided to name these particles that they found in the atom. They decided to name it they decided to name them subatomic particles. So considering these subatomic particles one after the other, get to understand a little bit about each of them. So let's get started. What are the three subatomic particles that scientists found? Actually, there are three subatomic particles. What are they? The first one they came across is the protons. The first one we mentioned is the protons. And then they also discovered electrons and then neutrons. I've not arranged them in order of discovery. No, it doesn't mean protons discovered first, followed by electron and then neutron. I've just arranged them in this way for easy remembrance. Why? Proton for P for protons, E for electrons, N for neutrons. Then we have pen. So for you to remember the subatomic particles properly or easily, to remember these subatomic particles easily, just remember pen, P-E-N. P for proton, E for electron, N for neutron. So these were the subatomic particles that scientists found to be present in every atom. So let's pick the subatomic particles one after the other. Let's start with the protons. What are they? What do we know about protons? Interestingly, the protons were found in the center of the atom and they were considered to have positive charges. So if you look at the model of the atom we have on the screen, at the center, which is the dense nucleus, we have some red spherical objects there with positive sign on them. Those are the protons. So the protons are found in the central nucleus and they have what? Positive charges. And this particle is called the proton, like we've been saying so far. Interesting thing about the proton is that it has a mass, and its mass is measured in atomic mass units. So protons live in the nucleus of atoms and they have a mass of 1 atomic mass unit. What exactly does that mean? Do not stress yourself too much about what the 1 atomic mass unit means. What it basically means is that if you pick the mass of carbon, and you divide it into 12 parts, 1/12 of the mass of carbon is the mass of what? Proton. Or approximately it's around 1.66 times 10 to the power negative 27 kilograms. So it is really, really, really light in weight. Yes, compared to the normal masses that we have around us. So protons live in the nucleus and they have an atomic mass of 1 AMU. Now look at this interesting point. We said protons are positive and they are found in the nucleus, have atomic mass of 1 AMU. But they have an important role that they play in every atom. What are those important roles? The number of protons decide what element an atom forms. I take that again. The number of protons decide what element an atom forms. What does that really mean? If you look at the model of the atom we have on the screen, the one on my right, if you look at it critically, you can see that the red spheres standing for protons, we have 4 of them out there. So you can see that this atom contains 4 protons. So if this atom contains 4 protons, it means it can form a certain type of element. That's basically what it means. So let's look at this periodic table and see. On this periodic table, you can see that it starts from hydrogen all the way to helium, lithium, beryllium, and so forth. But we are going to focus on beryllium. If you look at the top right corner, there is a number out there. That number is 4. That number is what you are referring to as the number of protons the atom or the element, the number of protons the atoms of that element contain. And the number of protons is what you refer to as the atomic number. In our next lesson after this, we'll actually be discussing what atomic numbers are into detail. So you can see that beryllium has atomic number of 4. Atomic number of what? 4. Meaning it has 4 protons. And hydrogen has 1. Helium has 2. So mind you, the number of protons a certain atom contains tells us the elements that atom can form. So it means that the kind of elements the atom we have on the screen can form is what? Beryllium. So this basically is a beryllium atom. Why is it a beryllium atom? Because it has only 4 protons. And it is the 4th element on the periodic table. Meaning elements on the periodic table are arranged according to increasing atomic numbers. So keep that main point in mind. Let's move on to our next subatomic particle, that is neutron. What do we know about the neutron? In our previous slide, we mentioned that protons are found in the nucleus. But if you look at the nucleus on the board or on the screen, we have some other neighbors out there that are in blue. Those are the neutrons. So the neutrons share the nucleus with the protons. But one interesting difference between the neutrons and the protons is the neutrons do not really have any charge. They have no electrical charge. But they have the same or almost the same mass as the protons. So that's one interesting difference and similarity. One, they share the nucleus with the proton, but they do not have any charge, meaning they are neutral, but their mass is almost the same as the mass of proton. But why are the protons or neutrons so important? Why are neutrons so important? What do you think? In order to answer that, let's pay a little visit to protons again. Why neutrons are important? Remember we said protons have positive charges. I'm sure you remember that. Protons have what? Positive charges. So imagine the nucleus contains only protons. Is that possible? Highly impossible. Imagine the nucleus contains only protons. Remember, they have positive charges. If they contain only protons, if the nucleus contains only protons, don't you think these protons are going to repel each other? Of course, because we said like poles repel or like charges repel. So if the nucleus contains only protons, then these protons are actually going to repel each other and the atom is going to collapse. So here's where the neutrons come in. So this is a little demonstration of what would happen if there are only protons in the nucleus. If there are only protons, positive, very close to each other, they will actually repel, push on each other, thereby destroying the kind of element they have to form. But this is where the neutrons come in. The neutrons end up acting like a glue, holding the nucleus together by holding the individual protons together. This prevents the atom from breaking apart. because the neutrons are hot, neutral. So this is what happens. We have one electron here, another electron here, and there's a neutron holding the protons together. Basically, that's what happens. They hold the protons together. So the neutrons are so important in holding what? The individual protons found in the nucleus of the atom. So without the neutrons, most atoms would not exist. Without the neutrons, most atoms would not exist. We are done with the protons, done with the neutrons. Let's finish up with the electrons. The protons and the neutrons are found in the nucleus of the atom, but the electrons are found outside the nucleus of the atom. They are not found in the nucleus. They are found outside the nucleus in orbits or shells. So the electrons are found in these shells, also known as what? Energy levels. Electrons also carry charges, but their charges are different from that of protons. The charges of electrons are actually negative. So electrons are negatively charged. And one interesting difference between the electron and the other two subatomic particles is the mass of electrons tend to be very, very, very small, almost considered as massless compared to the protons and neutrons. So when it gets to the mass of electrons, we just ignore it, just write negligible because it is extremely small. But atoms do not really care about sizes. Why do we say that? Electrons have very, very small size, mass. Yes, in terms of mass, they are really, really small. But although they have the smallest of mass or negligible mass, they control the chemical reaction of the atom, the bonding of the atom, and as to whether that atom, the element the atom form, will conduct electricity or not. What that means is that if you do not know and you change the electron of a particular atom, you end up changing how that atom behaves. If you change the electron of the atom, you change how the atom will behave. Meanwhile, when it comes to the proton, if you change the proton of an atom, then you have changed the kind of element that proton will form, atom will form. But if you change the electron of the atom, you've changed how the atom will behave, whether to undergo chemical reaction, whether to bond, or whether to conduct electricity. So although it is tiny, it is very, very powerful. So this table summarizes the three subatomic particles, their location, sizes, and then their location, masses, and charge in their atom. So let's pick the first one, proton. Protons are found inside the nucleus, and they are positively charged and have a relative mass of 1 AMU, which is approximately 1.66 times 10 to the power negative 27 kilograms. And neutrons are also found inside the nucleus of an atom. They are neutral, meaning they do not have charge, and they also have an a relative mass of 1 AMU. Meanwhile, electrons are found outside the nucleus. That is, they are found in the shells outside the nucleus. They are negatively charged and have a negligible mass. That's approximately, let's say, 1 out of 1836, or approximately 0, so negligible. So when it comes to exams, you can write negligible when it comes to their relative masses. So this table summarizes the subatomic particles for us. What is the relationship between atoms and elements? So far, we've been discussing atoms. What's the relationship between them? Here is it. Atoms are basically the building blocks of elements, as simple as that. Atoms are the building blocks of elements, meaning an element is made up of atoms. So we can actually define an element as a pure substance made up of the same kind of atoms. A pure substance made up of the same kind of atoms is an element. And all atoms in a particular element are the same. Basically, that's what we meant by the definition of an element. So if you pick an element like sodium, it's made up of sodium atoms. If you pick oxygen, it's made up of oxygen atoms. And oxygen atoms are different from sodium atoms. So an element is made up of the same kind of atoms. So it is considered as a pure substance. So let's pick some past questions as a review of what we've discussed so far. So what is an element? So an element is a pure substance made up of atoms of the same kind. Atoms of the same kind. So sodium has sodium atoms. Oxygen has oxygen atoms. As simple as that. And this particular question, that is, what is an element, is a section B question. Meanwhile, it was repurposed into section A questions in 91, 92, 2009, and 2020. So it's a hot cake question. You can define it as a substance made up of the same kind of atom is known as dash A, B, C, D, you choose. So it can be a section A question and a section B question. The next question, what is an atom? What is an atom? So to put it simple, an atom is the smallest part of an element that can take part in a chemical reaction. So I have an assignment for you. 2011, you can check your past question that I have. 2011 question 2D. So try your hands on this question. Interestingly, you can find the answer or the answers to these questions in this lesson. Mention the 3 subatomic particles and state the relative charge on each of the 3 subatomic particles mentioned below. Or mentioned above in the equation I. So you state the subatomic particles and their charges. So that's your assignment. So thank you for learning with us. And for our next lesson, we'll be considering the atomic number and mass number, which will be a continuation of this particular lesson. So after watching this lesson, do well to come back to watch the lesson on atomic number and mass number, or perhaps click somewhere on the screen. Maybe by then the lesson must be ready, so you can click to continue with this lesson, atomic number and mass number. See you in our next lesson.